Okay, so number 7 says that a UPS driver has already delivered packages to 12 houses and can deliver to 10 houses every hour. So this is like what we did before we started graphing, when we did the modeling linear equations part A, the modeling linear equations part B, okay? So hopefully you guys are good at this because most of you guys did pretty well on that quiz. So, all right, so remember, once again, we're talking about y equals mx plus b, because this is all linear. And remember, your starting amount is b, and m is your, well, it's your rise over run, but it's also the one that's going to happen over and over again, because you're going to go rise over run as many times as you need to. So this is over and over. And what I mean by that, you can do rise over run over and over again, is like on this one here, you went down 1 plus 1. I could go down 2 over 1, 1 more. I could go up 2 over 1. I could do it over and over again. That m amount, and the arrows mean I could even go past the arrows. I could keep going forever. Okay, so that's what I mean when I'm saying over and over. Okay, that m amount is over and over. Okay, so write an equation to model the scenario. So we have to kind of look at our amounts here. We have got 12 houses, and he's already delivered it to 12 houses. And we got 10 houses every hour. So the one that's over and over, that's every hour, is the 10. So that's going to go with the x. Don't forget the y. Some people just put 10x. You need the y equals. Okay? And then he's already done 12. Y equals 10x plus 12. All right, and then what are our variables? X and y, good. And what are parameters, Brianna? If you're looking at this equation, we already take the x and the y out. What's left? You have the x and the y are gone. What's still left in this equation? 10 and 12. Parameters are your numbers. Okay? When you're defining the variables and the parameters, you're looking at the equation to define them. Okay? You're getting the pieces of the equation. Okay? X is the word after each, every, per. That's right. So the word after every here is hour. The word, so we're talking hours. And y is the word that's usually after your numbers. So here we have 12 houses, we have 10 houses, so y is houses. Remember, with x and y, you want one word. You want something you can count. One word. With the parameters, you're going to want a phrase, a couple of words for each one. Okay? So with 10, it's going to be houses, but not just houses. It's houses every hour. Okay? And with 12, it's going to be houses, but you're going to back up over here already. He's already delivered to 12 houses. So it says now graph the equation and create a table of values for the first 5 hours. Okay, that's the part people are going to miss a lot of times. A table of values means this. And it says to go to 5, so let's do that. Like that. Okay? So let's label our x and y. We have hours here, and we have houses here. Okay? Which we can label our x and y here if we want to as well. Good idea to always label everything so that we're consistent. All right, so at 0 hours, how many houses has he delivered to, Rachel? Huh? 0 hours is already. How many houses did he already deliver to? Huh? 12. So at 0 hours, he's already delivered to 12. Right? And then how many do we do from there? What did we do from there? Sierra, what did we do from the 12? How much more houses is going to get delivered after the first hour? 10. So we're going to add 10. Then we're going to get 22, 32, 42, 52, 62. Now, I did forget to say this. This 10 is plus 10 and a positive because if you think about it, he's already delivered to 12 houses and he's going to 10 more houses. They're not taking away, they're adding to. So that's why it's a positive 10 and why we're adding each time. Okay? So then we graph it. At 0, we go to 12. At 1, we go to 22. At 2, we go to 32. At 3, 42. 4, 52. And 5, 62. And then we use a ruler to finish our line. With an arrow. Okay. So interesting, it says, when will the driver have reached 50 houses? So we can look over here. It's going to be somewhere between 4 and 5 hours. You can see that. Does everybody see that right here? It's going to be somewhere right kind of in here somewhere. But you don't know exactly, like 4 hours and how much partial hours, okay? You can also see that here, at 50, you can see that it's going to be, no, 50 houses is right here. Oh my gosh. I was thinking 60 houses. I don't know why my brain was off. 50 houses is going to be right here. So it's going to be 3 point something. Sorry for messing you guys up. Because 50 is before 52. You know, I know, kind of hard stuff for me right now. So I'll cross this off here. There we go. Okay. So it's going to be 3 point something. But we want to be more specific than that. So we need to use our equation. That's the whole reason why we wrote an equation, was so we could solve problems. So y equals 10x plus 12. That's our equation. And we know 50 houses. Well, houses is y. Houses is y. So this is y equals 50. So we're going to take that 50 and put it where the y is. Just like that. Now our x is in the middle here. Okay? The x is not by itself. Okay? The x is in the middle. And whenever the x is in the middle, or the variable's in the middle, we have to solve. Which means we have to draw the line and do the inverse operations. So we're going to minus 12 to both sides. And so we're going to get 38 equals 10x. And then we're going to divide by 10 on both sides. We're going to get x equals 3.8, which fits with when I actually did it right. In between 3 and 4. In between 3 and 4. 3.8. X is hours, so be sure to label it hours. When will he have reached 50 houses in 3.8 hours? It doesn't make sense. Can you have a partial hour? Yeah, you can. Because you can have 30 minutes, you can have 20 minutes, you can have 10 minutes, you can have a partial hour. So it's okay to have a decimal there, because a partial hour makes sense. Okay? So how many houses will the driver reach in 7 more hours? 7 more hours? Well, hours is x. So I could do this one really simply by simply adding 6 and 7 right here. If you do it that way, you need to draw an arrow up there to say how you did it. I could also do it really easily by looking at this. At 5 was 62, so therefore 6 is at 72, therefore 7 is at 82, right? So we know it's going to be 82, okay? Because I could just do this way and get 72, 82, and say 82 houses, okay? But sometimes they're going to ask us questions that we can't do so easily because it's going to be maybe like 52 hours or something like that, and you don't want to go to 52 hours because that's too long, okay? So then you do need to know how to do it with an equation in case you can't see it as easily the other ways. So it is x, so you're going to put that 7 in for the x. Right there. And if I do this, I notice the y is by itself. So I'm just putting this in the calculator. I'm not solving for anything. Y is already solved for. So if you put that in your calculator, you're going to get 82, which is houses, which hopefully you saw you could have done it an easier way. But if you do just write 82 houses here, you need to either have your table filled out, or if you did it from your thing, you need to come up here and have like dots on there so that I can see how you got that 82. I need to see something where it came from. But the algebra is fine, but other methods are fine as well. Whatever your brain tells you to do is fine. Is it getting too hot in here? No? Okay. All right, so I'm going to stop the recording.